Welcome to EDU World Space.
Hi, everybody. So we're looking at number 11, problem 11 in chapter 7 of Introduction to Modern Astrophysics. So this wants to know, this is asking, explain why radial velocity detects of extrasolar planets yield only lower limits on the masses of the orbital planets and what values actually measured and what unknown orbital parameter is involved. Okay, so extrasolar planets are planets outside the solar system. So we have our little solar system here. I guess galaxy. And here is an extra solar planet. Okay, it's out of our solar system. Our solar system. Out of our solar system. Okay, that way you guys don't get confused. There we go. And the extrasolar planets are much fainter compared to their stars, and that's because usually, and if we do this, let's say we have this star, it's this big, and the planet is literally just a little speck, okay? That little thing is the planet. So it's really hard to detect because we're over here. Let's say where this, actually, let's make us green. I don't know why I'm not going to make us green. That makes sense. Okay, let's say here, and we have this like many, whatever, light years away. It's going to be really hard to detect that because the star is in the way. Okay, so the detection of the extrasolar planet is quite difficult. And so the detection involves indirect methods such as radial velocity measurements, astronomic wobbles, and eclipses. This quite possible technique is radial velocity measurement. So we have radial velocity measurement. Okay, I'm going to put here. And from the radial velocity measurement technique, and we'll put technique here so that way we can. Okay, and that's one of the reasons. So from this technique, the shapes and sizes of extrasolar planets are discovered. So we can put it down in green. Shapes and sizes are discovered. Okay. And the planets detected through this technique are close to their star and very massive. Discovered, but have small orbital orbit. We'll say small orbit. Oh my gosh. And are massive. So think of that, it's easier to see a Jupiter than it is to see a Venus. Okay, and another planet. The planets detected through this technique are close to the star and very massive. The mass of the planet is determined by periodic movements with a common center mass. The technique provides only lower limits. Okay, the low limit of a mass of extrasolar planet is of. Okay, let's get this down here. Okay, the low limit of mass, because the second question of this whole thing is asking us what value is actually measured and what unknown orbital parameter is involved. Okay, so the low limit mass of an exoplanet, let's say Gliese 581c, is determined by this technique, and it's determined to have a 5.6 Earth mass. Okay, but the actual mass is, and the actual, let's say the actual is 7.7 Earth mass. Thus, the radial velocity measurement method detects only the lower limit mass, and this is lower limit mass. Okay, so that means that the lower limit mass, the radial, that red here, this lower limit mass right here is found through the radial velocity measurement, which we explained right here, okay, right above. But it's only found the lower limit of the mass, so the lower, one of the lowest possible limits. And with this technique, the measured quantity is, so the measured quantity is m sine I, and unknown, and the unknown orbital parameter is the inclination of the orbit. Okay? Thank you guys.